Okay, third lesson on binomial expansion. This bit deals with using partial fractions. If you've got quite a tricky algebraic fraction like this and you want to find a binomial approximation for it, or an approximation for it using the binomial expansion, then dealing with it as it is would be a nightmare. So what we're going to do is we're going to split it up into partial fractions first, and then we're going to find the binomial expansion of each of those partial fractions. So we know this is going to be a over 1 plus x plus b over 2 minus x. This is actually example 7 from page 101. They find out the partial fractions by using substitution. I'm going to do by equating the coefficients. So adding these two together, you get a times 2 minus x plus b times 1 plus x over 1 plus x 2 minus x. So this has to be the same as that. Just looking at the numerators, this numerator therefore has to be the same as that. So therefore 4 minus 5x must be equal to, now I'm going to multiply this out and bring the numbers together and the x's together. So we'll deal with the numbers first. So that's a times 2 plus b times 1. And now the x is minus ax plus bx. So the number 4 has to be the same as 2a plus b. So therefore 2a plus b has to be 4. And minus a plus b has to be minus 5. Minus a plus b has to be minus 5. Two equations, two unknowns. I'm going to do the first equation, take away the second equation. That way the b's will cancel. 2a take minus a is 3a. That equals 4 take minus 5, which is 9. So a is therefore 3. And if a is 3, then b has to be minus 2. So I can now rewrite my original question as 3 over 1 plus x plus minus 2 over 2 minus x. And it'll be a little bit easier to find the binomial expansion for these two and then add them together than it will be to try and do this thing all in one go. Right, so binomial expansion for these two. Let's rewrite the first one as 3 times 1 plus x to the minus 1, and we'll expand that. We're going to expand that using the formula we used, or we saw in the last work we did. This is the expansion, the binomial expansion for expressions like this, where n is not a natural number. It's not a nice, neat, whole, positive number. It can be negative, it can be fraction, it doesn't matter. In our case, it's a negative. So we've got a 3 outside. Now I'm going to expand this thing. So 1 plus n times x, that's just minus x, plus n times n minus 1, minus 1 times minus 1 minus 1 times x squared. It's just a positive x here, so x squared over 2 factorial. I'm going to do one more. I'm going to go up to x cubed. So that's minus 1 times minus 1 take 1 times minus 1 take 2 x cubed over 3 factorial. Now we'll just expand that. So 3 times 1 is 3. 3 times minus x is minus 3x. Minus 1 times minus 2 is 2. 2 over 2 is just 1 times the 3, so it's plus 3x squared. Minus 1 times minus 2 times minus 3 is minus 6 over 6 is minus 1. So I've got minus 1x cubed times by the 3, so it's minus 3x cubed. So that is the binomial expansion, the first 4 terms of this expression here. I'm now going to do this one. Minus 2 times 2 minus x to the n. Now if we go back to the formula, you'll see that this number has to be a 1. To get this to be a 1, I need to take a factor of 2 out. And this isn't an n at all, this is a minus 1. So I'm going to take this 2 out. So I've got minus 2, taking a factor of 2 out of here. So that's 1, take x over 2, and this thing is to the minus 1, and that's equal to minus 2. 2 to the minus 1 is a half, so it's minus 2 over 2, which is minus 1. Minus 1 times 1, take x over 2 to the minus 1. So find the expansion of this, multiply it all by minus 1. So we've got minus 1 times 1 plus n times x, both negative, so it's a plus x over 2, plus minus 1 times minus 1, take 1, which is minus 2 x over 2 squared, and it's a minus over 2, and the next one is minus 1 times minus 2 times minus 3 minus x over 2 cubed over 3 factorial. That should be 2 factorial, and we'll stop it there. This could take a little while to work out. 1 plus x over 2. Right, scope for error here, I think. So this is minus, but it's squared to make it positive, so that's x over 4. This is 2, so you've got 2 over 4 divided by 2, which is a quarter. But it's minus, no it's not, it's a positive. Sorry, that was right in the first place. Now let's do the last one. Minus 2 times minus 3 is positive 6, times 1 is minus 1 is negative 6. This is going to be negative because it's minus x cubed, so we had a negative times a negative would make a positive. 2 cubed is 8. So 6 over 8 divided by 6, which is an eighth. Okay, and now we add our expansion from the first one and our expansion from the second one together. Let's just multiply all this out. Minus 1 minus x over 2 minus x squared over 4 minus x cubed over 8. So I'm now adding these two expressions together, and that'll give me my final answer. Deal with the numbers. 3 plus minus 1 is 2. Minus 3x minus x over 2 is, we ought to write that as minus 7 over 2x. X squared, 3x squared minus a quarter x squared is going to be 2 3/4. So that's 11 over 4x squared. Now the x cubed minus 3x cubed minus 1/8 x cubed is 23 8x cubed. No, it's not, because that's minus 3. Take away that, it's minus 25 over 8x cubed. So this is the binomial expansion, the first 4 terms for this. Very long-winded. I assume you had to press stop, rewind, pause all over the place. That's fine.